Okay, we are going to jump in the middle of a project this time instead of starting something from scratch. Good morning, y'all. Let me see. I need to find my, where's the page that describes what's going on so that I can see comments and people showing up and all that kind of stuff. This one I was accidentally I've been streaming to absolutely everybody live, and then with the videos uploaded afterwards, which was not the original intention. The original intention is to stream only to you, the paying subscribers, live, and everybody else can figure it out from there. Hey, Substack, where's the page? Scheduled past, canceled. No, none of that. Okay, I'm gonna go look for that in a minute. And right now, I'm just gonna stick to doing the work. We got a genie. We're back in Augment Code's intent. Interesting experience. It's early days, and I find myself quite effective with it, even though there's assumptions it makes that aren't mine. So anyway, here we go. The project is the adaptive radix tree. So we want a sorted map. We have keys and values. We have get, put, and delete of keys. And we have iterate from key to key. So that's the basic API. We've seen that in B tree. I think I did an adaptive radix tree version. Let's see. Gosh, I really wish that I was able to see if anybody is listening, because you never know. But I should be live, so we'll see what happens. Okay. If wishes were fishes. Hit me up on Substack chat. Actually, I'm enjoying Substack chat as a way of talking to the paying subs, which is you all. We'll see how many of them there are. Okay, so we have the adaptive radix tree, sorted map API. The implementation is fun because it's rather than being a tree like a B tree or B plus tree, it's a trie, which is a tree structure that branches on every character, in our case, every byte of the key. And so if you have if one key is 1, 2, 3, you'll have one level of the tree that captures the first digit, let's say. Second level of the tree captures the second digit, and the third level of the tree captures that third digit. So on 1, we'll go to the first child, to the 1th child, and then 2, and then 3, and then we can find the value. So that's how it's intended to work. And the adaptive part is the cool thing about the adaptive radix tree. The adaptive part is, so sometimes you have another byte in the key, and sometimes that byte has no siblings, or hardly any siblings, let's say 2 or 3 siblings. Sometimes that byte will have 255 siblings. Yes, 255 siblings. And the whole thing will be very, very bushy, as to be this long string that's with lots of unique bytes. So we have 4 different representations for nodes in this tree. We have one which only has 4 children, up to 4 children. Then we have another one, and that's just linear search because it's zippity fast. We have another node which has up to 16 children, 5 to 16 children. And that one, I mean, we can look at it. I think that uses a binary search, or maybe still uses linear search. Then we've got up to 48 children. So 17 to 48 children, that definitely uses binary search. And then we have one for more than 48 children where we just have an array. We just assume we're going to have a value for each, or a child for each value the byte could take. So we just index into an array. So as we add to this trie, as nodes get bushier and bushier, they change shape depending on how many children they have. And as we delete, we do the inverse. So it's a complicated thing to get right. I did this implementation in Go, which you can find on GitHub, assuming it's up, as art sorted map 2, I think. I think this is, yeah, adaptive Radix tree 2. There we go. Oh, it's up here, right up here. Adaptive Radix tree 2. Because I had to throw away the first one because, yeah, you know, the genie. So, where were we? We've got the, okay, so I've been working on this particular version for quite a while. I have something that's faster than the other sorted maps that are out there. Google has a B tree that's pretty fast. There's another art implementation that's out there that we're kind of comparable with. And so and it's pretty rock solid. I have a fuzz tester. I have run mutation testing on this. I'm pretty confident, and I haven't seen a test breakage in quite a while, so I'm pretty confident. I could be more confident, and I've been going back and forth on this old saying that my pops told me. My pappy told me, make it run, make it right, make it fast. And we all want software that's all of those. The question is how to get from where we are now to something that is clean code, that works fast, that we can change. So that's a harsh set of constraints to engineer against. Clean code means that we're able to understand it and change it, analyze it, predict where it's going to have problems, address those problems. That works means that any reasonable sequence of inputs should give us the expected output, and any misformed inputs we give it should be rejected, not just corrupt the data structure. So it's clean code that works, that's fast, and this is where, you know, I haven't done a lot of performance tuning in a while, but oh, I love doing it. It is so much fun to figure out how much pressure is there on the memory subsystem, and if I align, I've had cases where I had 40% performance regressions that just resulted from because the size of the functions changed, the alignment of the object code in memory made the caching the memory caching part of the memory system puke. I love that. Those are the kinds of problems that I can solve with my brain. So happy doing it. Let's see. I'm still not seeing anything on chat, so maybe nobody's listening, but then this will just go out. Whatever. We'll slice it up into shorts and it'll interleave with all of your whatever it is you watch, short videos. I've been watching a fair number lately. I needed distraction. But I also have been coding my brains out and having a great time. So there we go. Okay, so we have an implementation in Go, which is its own set of interesting constraints. I did the first art I did was in Rust, and I was able to use the low order bits of the pointers to the nodes to tag the different kinds of nodes. In Go, you can't do that because it's the garbage collector will look at that and think it's a pointer to misaligned memory and blah, blah, blah. You're done. So the Go one is under different constraints. That's part of what I'm doing here is trying to do the same thing over with slightly different initial conditions to find out. I would call this sensitivity analysis. I want to find out what augmented development is sensitive to. Does it matter what order we implement the tests in? Does it matter what priority we put on readability versus the next feature? Does it matter this? Does it matter that? The wording of the prompts, all of that stuff. And so I need to do pretty much the same thing, but very near as I can tell, one thing at a time. So that means I'm going to be doing the same thing over and over again with variations and seeing what of those variations really matter. So, where are we now? Okay. So I have the implementation in Go. It works. I haven't had a test case break in a while. Except Go pukes on minus 0.0 as a floating point number. Oh, I didn't type it, but the genie did, and Go compiler didn't like it. So that was a learning. Don't do that. I've been working on performance. Some has made the code harder to read. I've been working on readability. Some has made the performance worse. I tried Go's version of polymorphism, which seemed to clean up the code. There were a bunch of switch statements which said four-way switches if it's this kind of node, if it's the up to 4 node, the up to 16 node, the up to 48 node, and the up to 256 node. They were just over and over scattered all over the place. And I think that I pretty much got those. So let's look at some of the Here's the prompt. It's kind of, I don't know exactly where we stand. We'll go look at the code in just a minute. But I wanted to give the genie this prompt. Wipe the plan clean, because intent has an internal to-do list. Wipe it clean and rewrite from first principles. We want a sorted map that is absolutely reliable. So I want to be as controlling, as domineering, as certain as it possibly can be. This is a fundamental data structure. People are going to rely on this. It has to be absolutely reliable. Every conformant sequence of inputs gives the expected result. Every non-conformant sequence of inputs is rejected with an informative error message. So that seems to me like a reasonable qualitative goal. It needs to be fast, faster than the currently available alternatives, whether art-based or B-tree based. So the performance, oops, I accidentally changed the size of my screen. So let's fix that. There we go. Bink. There we go. I was able to get put and delete all faster than the B trees by a considerable margin in some cases. Iteration is slower, and that's because the B tree has several values clustered together in memory, and the try is necessarily the values are going to be spread out. So that's okay, but I would like something that's as fast as possible. Next one, and this is something I've been playing with, I want this code to be human readable. So the code itself, the first time I said, make this readable, comments. It had 10 lines of comments for every line of code. And that is not readable. Absolutely not. So code itself should provide an interested reader with a tutorial on art. That's what I want. I want the code to be so clean that I'm never bogged down with implementation details until I actually care about that. I want to get a high level sense of what's going on. And then I want to be able to dive into the details that I care about. Comments are only for API documentation. Now that's the exception. I want the code to communicate as much as possible. And I think it's possible to make it communicate much more than it has been. API docs is the exception to that, where this is a sorted map, and we should say, here's exactly what the API looks like. So that interested readers from the outside can look at that and make a decision. It's very different than, okay, I'm getting slow performance in some case. If you see my eyes go up, it's because I have a lot of birds flying around in the backyard, and so they're always interesting. Not great for the boredom sensitive like me. Okay. Anything about the implementation that can't be expressed through code, we should work harder so it's expressed clearly through the code. I want to tell the genie, you're here to serve the people, not the other way around. Implementation comments admit failure. If there's one, that's my pull quote for, I think, for this whole thing. And then I also want it to be genie readable and changeable. Now this is interesting. I wonder if there are going to end up being trade-offs between, okay, the genie can do it. The genie can read and manipulate this code, but humans can't even understand it. It's like APL code or something. Or vice versa, here's code that's easy for humans to read and the genies can't handle it. I kind of doubt, my working hypothesis is that if it's code that's good for humans to read, the genie is going to be able to manipulate it pretty well. But the genie is not going to take care of that, even its own ability to understand, without a clear mandate from the programmer. I know this is a difficult set of constraints. Boo-hoo, we can do it. Okay, so I'm just going to issue that, and I'm going to see what it comes up with. Now, while it's chewing on that, let's go look at the get code. Get returns a value previously stored under key. If any, if the key is absent, the return value is the 0 value of v. A nil key and an empty slice key are equivalent. Both represent the empty key. Okay, so we take an array of bytes as the key, and we're going to get it. And this one is a loop. We have the root of the tree. We keep the depth. I don't remember why we keep the depth, but I can find it. This consume prefix. Oh, there's some interesting corner cases. What if you have... I don't think I can explain it yet. So we'll get to that in a minute. While current's not nil, we grab the... If... let's see. If... L is not a great name for this variable. So this looks like the end of the iteration. One way to get to the end of the iteration. Here's another one, which is the D is the depth. Oh, consume prefix. Okay. What's going on? Okay, so this is not easy for me to read. Kind of the sense of it that I get is we're at some node, current. We find the next child for the next byte, and we increment the depth, and now we're going to keep going until we hit nil. And we have some cases. Here's 0 and false. We don't match, the bytes don't match. And I don't understand what's different about those two cases. So we have some understanding to work on. Let's go see what the coordinator has given us. Read the current. Oh, okay, so it's still chewing. So I just have to rip. Oh, here it is. Thank you so much. All right. Current state of the 4 goals. All right, we're going to have some stuff to read here. I'll just scroll back. We'll get it. Sorted map in Go backed by art that is reliable, fast, tutorial readable, and genie readable. There you go. Tensions, fast versus tutorial. Helper extraction and hot path closures, regressed by 20% and another 6%. Type method dispatch where the inliner sees through is fine. Arbitrary helpers are not. So this is a limitation of the Go compiler, I would say, that it's not helping me make readable code fast. But that's okay. I mean, that's just the constraint we have to deal with. Reliable versus has bounds, nil, contract checks, cost cycles. No, they don't. Okay. Pay those checks at the API boundaries, because inside we can prove, at least informally prove, properties of our inputs. Internal calls trust each other. Okay, that's absolutely my philosophy. API boundaries, I'm going to be very suspicious, but inside of my own code where I can look at the caller and I can look at the callee, I'm going to prove properties and use that to simplify the code, make assumptions that simplify the code. Tutorial versus Genie. Tutorial wants a reading order, simple to complex. Genie, reading order, I mean, that's from Tidy first, so good on you for figuring that out. Genie wants locality. Everything to edit X is near X. So this is a cohesion argument. Links declared in package doc. Okay, well, we're going to see what it comes up with for suggestions. No implementation comments versus invariants. The N12, I don't remember what N12 is, so that would be helpful. Is by the new rule a structural confession. Ha! The fix is to remove the alias, not document it. Yes, correct. And the current stage. Mutation score is 100%, fuzz cross checks, and we use the current map as an oracle. No single contract document. Now that would be, it'll be interesting to see what it comes up with. We'll ask it to do that, because we can ask it anything. I don't know if you remember, we asked it to write a fairy tale once, and it came out okay. Mixed misuse handling. New node width panics on equal keys. Range and start where end is less than start. Silent loop iterates empty, undocumented. Okay, so yeah, we should have better checks at the API boundaries. In coverage gap, prefix target ends here in ceiling floor. Oh, that's interesting. I was my total and absolute confidence was misplaced. Okay, so am I seeing any chats? No, I'm not. So let me know if you're out there. Would love to talk. We'll see what happens. When on get, 3x, get, miss, put, delete, and versus one of the popular B trees. We lose on range by a factor of 2.4. So, I mean, if we're reaching the theoretical limits of what the adaptive radix tree can do, I don't mind. I don't have to do impossible stuff. Comparison versus plar exists in the bench directory, but not rebaseline since the polymorphism merge. Okay, so plar Go adaptive radix tree is another implementation of the same data structure. But apparently, the benchmarking takes like 30 minutes to run, and I run out of machine time before it finishes. Polymorphism merge, bench drift unmeasured. And I think this means that we introduced polymorphism to try and make things more readable, and we didn't measure how much slower that made things or faster. File layout is operation centric, not type centric. Reader can't build the model bottom up. Okay, so this is, I'm not sure about this. We're going to see. And yes, we will get to doing some actual work here in a few minutes. I want to just get oriented, and I've been working down in the weeds of this thing for a couple of weeks, and I want to pop my head up and say, all right, hang on, what are we doing here? There's 80 plus implementation comments, each a structural debt. Yeah, okay, fine. So, file layout. Should we have a file for each of the node types, or should we have a file, as we do, for each of the operations? Delete got, this is one of these things. Which, I mean, this doesn't look horrible, although we have some stuff clearly from the get that we have to understand a little bit better. This kind of wall of text and a tiny bit of code, come on. We can do better than that. Okay, so I'm not sure which file layout. One of the interesting things for me is that maybe we don't care about files and folders anymore. You just put it in one, basically in one graph database. Is it random that I'm saying graph database? It is not, dear reader. We have 80 implementation comments. These are structural debt. Yep. Polymorphism failed. So I tried introducing polymorphism once, and it failed. And then we had this this document left behind, which has been actually useful. So I think I like that. Mirror pair duplication partially deduped. Okay. We had cases where we had the same code, like iterating forward versus iterating backward, and it was almost exactly the same code. So would love to dedupe that. Genie readable, functions mostly less than 30 lines of code. Okay. I didn't know that was the cutoff for genies, but fine. Types that go to, yeah, this is too big. This seems too big for both genies and for us. Let's go have a look at it, even though maybe we're not going to stay here for very long. We have the different kinds. This iota thing, I learned that about Go. This is how you have start constants at 0. We have the leaf nodes, which store a key and a value. And then we have these 4 sizes of nodes. And there's the capacities. Node is an interface from which you can fetch the kind. Every inner node has the following operations. Maybe we can narrow this to some degree. We'll see. We'll see how we do. Reshape and shallow, what do those mean? Okay, that's I'll put that on the list. And then the leaf has the whole key and a value. Inline key max. I need an explanation of that. Okay, I said we weren't going to spend very long. Hokey smokes, look at this. And then each of those operations, there's reshape. Demotes or collapses in after a child removal or terminal clear. Child removal or terminal clear. I don't know what terminal clear means yet. Node 4 has unique one child plus no terminal collapse case, where the lone child absorbs the parent's prefix and branch byte. Okay, fine. And then we have node 16. Blah, 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 blah. This code kind of looks similar, don't it? To node 4. And then there's here's how to grow it, shrink. So each size needs to know how to grow and to shrink. I wonder that. Anyway, node 48, find child, add or grow, replace child, remove child, each ascending. So this is all the same operations. Grow to 48, shrink to 16. Okay. And then 256. So notice that the 256 ones are much simpler. We don't have to go searching for anything. We know exactly where each one is. Remove child. Nil. Each ascending, each descending. Reshape. Grow. Shrink. Collapse empty. Merge prefix. Okay, so that's... I wonder if we should have... Well, here's the weird thing. The code is so similar. I'd love for it to be either the same or clearly differentiated. But, Anyway, we'll think about that some more. We have another half hour. I'm just going to keep reading the output. Work streams. Specify the contract. Single source of truth for every public methods, pre, post, misuse, edge cases, backfill tests until every contract clause is covered. That sounds like a good thing to do. Maybe not exciting enough for what we're doing, but okay. The benchmark, rebaseline, and range allocation elimination. We can do that when we're finished, I think. Always a question of when do you change structure and when do you change observable behavior? And no perfect answer because you're making the decision with imperfect information. I played poker last night, so I'm feeling that. Restructure for type-centric layout. Leaf, node 4, node 16 with ops as methods. Operations spanning types get their own files. Range and ceiling. Bench gated waves. Waves are what intent calls sequence of PRs, something like that. Eliminate implementation comments. Strict policy. Each. Ooh, I like, now we're getting somewhere. I'm not sure I want to do this until I've done some restructuring first. Eliminate aliasing fragility. Kill the... Now this looks... Okay. All right, so it says, let's do this, specify the contract. First. Go convention, panic for programmer errors, error for IO class concerns. All sorted map misuse is programmer error. Default, panic with descriptive message, no error returns. On get, put, delete, range, ceiling, floor. Confirm. All right. Well, I mean, do the Go thing. Whatever Go says we should do. If we sorted map misuse is programmer error. Go convention. I'm getting my head around this. Go convention, panic for programmer errors, and error for IO class concerns. So if somebody says put with a nil key, all right, we're going to have to narrow down what we're doing. I tend to agree with the specify the contract. W1 is the first priority. Let's nail this down. I thought it was nailed down pretty well, but I wasn't paying close enough attention. So we're going to do that. And I guess sorted map misuse is a programmer error. Yeah, I'll go with that. We're being given bogus input. Something horrible has happened. The rest of the computation cannot proceed with any degree of confidence. Okay. Go Radix, be bolt in memory mode, standard lib, sorted search, default the first three. Oh, well, I don't know. I don't want to think about that yet. Big one-way door. Type-centric reads as art the data structure. Operation-centric reads as map the API. Default type-centric. Well, I'm not happy with types.go as it currently stands. I kind of want to see those various operations for all four internode types all next to each other. I mean, okay, back to first principles thinking, coupling and cohesion. Are we going to change the same operation on all four types at the same time? Is that more likely? Or are we going to change a bunch of things about delete at the same time, or a bunch of things about a given type at one time? Is that more, which one is going to be more common? Wow. See, here's where I wish you were sitting right here. We go make a coffee. We'd walk around, we'd ID some of the birds using the Cornell bird ID program, and then it would come to us which way we should go. So I'm just going to take a guess, and if I was live with y'all right now, I would just start, I'd ask you what you thought. But here we go. Tutorial structure. I think... Here's what I'm afraid of. If we separate the types out into each into its own file, then the commonality between the node types becomes harder to spot. So so bigger lesson is there isn't one structure for the code that's the right way to do it. There are different structures for different purposes, and as the code grows and as the stresses on the code change, the optimal structure may also change. Okay. Comment elimination, strict or pragmatic? Strict, no, zero non-go doc comments allowed. Okay, so not strict. Pragmatic, which means our job, number one job, is to communicate with other programmers. Our number one medium for that communication is the code. This is my personal philosophy, and I understand a lot of other people believe different things, and fine. But especially in the Genie era, when you can just say, explain this to me, and get an explanation. Yeah, I don't see, anyway, lots and lots of comments. Only flag comments that hide a code smell. Yes. So looks like it needs me to answer some of these questions. Concurrency story, keep locked tree wrapper, yes, for the moment. It would be really interesting to build a highly concurrent data structure and see how the genie, like, what is our workflow for that? How can the genie help? Can we do model checking? Can we do all of that cool mathy stuff? But that's not what we're doing today. Backward compatibility to satisfy goals. Struct. Okay, yeah, breaking changes are certainly allowed up to version 1.0. Okay. Pick on the questions first. Okay, so we're going to answer these questions and then see where it goes. Misuse handling, panic versus error. Okay, so 1, malformed inputs, nil key, range where start is greater than end, etc. Our programmer errors. Do the go thing. All right, so we're going to tell it that. Question number 2. Interesting that it asked this as a set of questions. I'm not sure I've seen that before, but I like it. Performance targets, I don't know. You decide. We want to give potential users my typing. Okay. I tried speaking to do this kind of stuff instead of typing, and it didn't work very well. But Parkinson's is saying give dictation interface another opportunity. So I'll do that. So okay, so back to give potential users the information to make a wise decision about whether to use our map or use something else. Yeah. Question number 3. What is question number 3? Tutorial structure, type-centric versus operation-centric. I think both. The file per type with the type specific code. Also file per operation like we have now. See how that comes out. Yeah, that seems reasonable to me. I'm just making some comment elimination, pragmatic. The goal isn't to eliminate comments. The goal is to communicate clearly, and code is a great way to communicate. Let's see here. 5. Concurrency story. Same. Backward compatibility. I've not looked at this range versus bounds. 6. Correct. Nobody's actually using this yet that I can find, so we're just going to go with this. All right, so now I'm answering the question. I'm not sure what it's going to do with those answers. I suppose it's going to come up with some sort of a plan, and that's fine. We'll see that. It says here I've been streaming for 45 minutes, so that's something. Yeah, I got up today and I was inspired. I kind of like that prompt that I wrote. I don't know if it's effective. It'll be effective with a genie. But yeah, I think now I shouldn't say this. I'm curious which model is being used under the hood here. And I don't know a good way to find out. Can change the fonts, attach files, enhance the prompt, stop. Okay. So it's chewing on that for a while. Here's where usually I would go to the comment section and say, hey, how's it going? But for whatever reason, I don't see that. So, yeah. So I usually stop these at an hour. I get tired. This takes a lot of concentration. But that's okay. If it was easy, anybody could do it. All right, so where are we? The spec is rewritten. Okay. Recap of decisions captured. Yes. We have a bunch of, we have 2 arts and 2 B trees. Yep. To compare to file per type and file per operation. Yep. We don't even know if that's going to matter in our augmented future. Pragmatic comments, code is primary, comments where code can't reach. Yes. Locked tree. Yes. Breaking changes allowed up to 1. Yeah. Standing principles. Bench re-baseline. Do one, so I wanted to, I don't really care about this. But about the performance right now, but okay, having a baseline before we got started with this, that makes some sense. So we can do that. And this, yes, this specifying the contract and locking it down. So this seems really important. We're trying to build a data structure that can be absolutely trusted. And so we're going to give that a shot. And once we can trust it, we should be able to keep trusting it. The changes that we make should never break anything, or else. Then the split into the per type files. Yeah, it'll be interesting to see if that helps. Like, do you make changes across operations? Like across the types, the same operation in different types, or do you change several parts of the same type at the same time? That is just the absolute classic. And then we have some performance tuning that we know we need to do because we're allocating temporary objects where we really don't need to. There's some aliasing stuff that you just shouldn't. And then, yeah. Let's do 1 and 2 first. Because we can kick off a benchmark run. Just let it churn. May not get done before we finish. We have about 10 minutes to go. So we'll see what happens. I really hope this is going out, because if it's not, I spent an hour talking to myself. I'm still getting stuff done that I want to get done, so I'm relatively happy. I just would like it to be useful to other people as much as possible as well. So, and then the second question is, this is not going out live. What went wrong? And what can we do about it? Because I thought this would be. I generated a stream key. I started it up. Everything seemed to be starting just fine. So we'll see what happens. Okay. We're getting somewhere. Oh, would be nice. I wonder if the Go testing framework can test for panics. That's something I can ask. Okay, so here's a thing. Maybe I should. Maybe I can just start another agent. Developer, PR reviewer. I just want somebody to answer questions. Okay, and what did I just say? What were we working on? Oh, can the Go? There we go. Can the Go test runner that we're using test for panics? Always ask the genie. Just my hard and fast rule. Learn it from Josh Cannon. Always ask the genie. Go's testing package supports panic testing through a few standard patterns. There's no dedicated assert panic helper, but the idioms are well established. Defer func. Okay, so there's a recover. Okay. Helper function for use. Okay. Yeah, we just pass a closure to it. Good. And where's our coordinator? Here we go. Their file disjoint. Yes. Independent outputs. Hey, I got two genies going at the same time. I have the hardest time getting two genies not to be stepping on each other's body parts. Current key shapes against. Oh, here's where Adrian Cockcroft did this fun project called Retort. And he was talking about, I'm blanking on the name, from statistics, about where you got a multi-dimensional array of factors. You have multiple factors on multiple dimensions, and you don't want to just test the cross product, but you do want to know which factors matter. So here we have different kinds of keys, we have different operations, we have different implementations of the sorted map, we have different sizes of trees. Multiply that all out, and we got, until the heat death of the universe. So, yeah, let's see here. Okay, so the benchmarks and the public contract specification. Documents, surface to inventory, tree, exports, get, put, delete, iterate, sorted, Types? Why are sorted and types necessary? I don't think so. Okay, so we'll, I'm going to ask about those. I don't want the types to be visible outside of this package at all. Precondition and postcondition, panicked edge cases. W2B, that's the second part of it, to write new tests. We're getting close to being done. I still don't have any confirmation that this is going out, so whatever. Delegate both as one wave. Okay. That's something I'm still getting used to in intent is intent shows you these options and then you pick one and then the options disappear, which I kind of find disconcerting. The options for the next step. I want to keep seeing, okay, sort of, it's choose your own adventure, which is great. I love the metaphor. I just want to be able to look back and say, here are the choice points. You could have done 3 things the previous time. You chose the middle one, then you could have done 4 things, and you chose this one, and then you could have. So I have some sense of progress towards a larger goal. It's hard for me to keep context in my head of where exactly we are. Okay, so we're working on performance, but how far have we gotten and how far do we have to go? I could use help doing more of that. So, you know what? I'm going to call it. It's a Friday. I'm finished. I hope that you've been enjoying this. I hope you take some good lessons from it. Like, comment, share, do all that good stuff, no matter where you found it. And have a look at this this repo if you want to see what happens next. Because I'm kind of on the trail of all of the things that we've specified doing. I want to see the results of doing all of them. So I'm going to do that. I hope you have a peaceful and restorative weekend. Remember, I was going to say something snarky about 996 or the modern equivalent 5100. 50 weeks a year, 100 plus hours. Software development is a game of insight. And insight comes to the prepared, rested mind. And with that, I will talk to y'all later.